Welcome everybody. Welcome to this first Movella Sports Conference. The Sports Conference is about combining sports and kinematics. And today our aim is to give you valuable insight into different tools that can be used and combined for performing analysis in research and in sporting environments. This also includes a detailed look at the latest innovations for measuring human motion in sports, such as EMG, force plates, but also software applications that can calculate kinematics. During this sports conference, our speakers will share their insights about the technology and the application in motion capture. We hope that by showing the innovative combination of analysis tools for researchers and sports scientists, that they will learn new ways to investigate an athlete's performance capabilities. Okay, hello everybody. Our next session will be about smart clothing technology for sports, well-being and physiotherapy. It will be hosted by Pekka Tolvanen from Myontec. Pekka, welcome to the webinar. Thank you very much for speaking at our conference.
Thank you again for inviting Myontec to this webinar. My name is Pekka Tolvanen. I'm the founder of the Myontec company 14 years ago and currently working as a senior advisor. So I'm going to talk about the smart clothing technology that we have developed for sports, well-being and physiotherapy. There are also some other areas where our technology can be used, but that's for the future. So something about the agenda today. I'm going to present a little about the company, our mission and the philosophy that we are using to measure human performance, including the key benefits, how they help to analyze the performance, and also I'm going to explain the technology partly in detail, but partly also how it can be used in different applications. So our technology is currently called Mbody, Mbody 3, that's our third generation technology. The first one was developed during the years 2004 to 2005, something like that. And then currently, now we have this third generation version. And the key benefits of our technology are the accountability and versatility. And the philosophy is that the products are intended especially for field use applications. They can be used in laboratories, but the most important areas are the fields in sports and ergonomics and similar ones. The Mbody 3 product consists of hardware, different kinds of smart clothes, accessories. Then we have 2 different Windows software. We have mobile apps. And then at the end, I'm going to show you some of our selected product examples, how they are used. Myontec is the EMG analytics company. As Jonathan from Delsus explained what EMG is, that was very excellent presentation regarding the technology, how the EMG works and how it will be used. We are using exactly the same principle technology, but our core is to make things very simple and easy to interpret. And therefore, our focus areas are the sports, where our customers are individual athletes and sports teams. And the other major area is ergonomics and well-being. And for those areas, we have developed the whole concept, including starting everything from the sensors, ending to the cloud service-based reports that contain simple explanations what is the problem, for example, during the work, or how the athlete can improve their performance in their activities. Something about our journey so far. Company was established 14 years ago, 15 years ago, and our first real consumer product was launched 2014. That was called Mbody, and that was the second generation. And then over the years, we have developed new concepts for team sports, for rehabilitation, and then for the ergonomics. And now we are scaling up this technology for these major marketing areas like sports and ergonomics, and then providing our technology as OEM for anyone who would like to see EMG in their products. Over the years, we have reached several good reference customers in sports teams, Olympic training centers, and also in the occupational health ergonomics area, big industrial companies throughout the world. The latest one is the North American Occupational Health Institute in the US. Our technology is really patented and it's validated since 2002 already. And there are over 70 different scientific articles published showing how the technology is used in different applications and how it can be used to give results for all these areas. How our technology and principle differs from the traditional EMG. This picture shows the core idea. So what we measure muscle groups instead of single muscles. But the idea is that we measure muscles which are anyway functioning synchronically, usually agonist or antagonist muscle groups. So that means that we can reduce the number of measurement channels, but still get more information from the muscle area from the person. And then all the sensors, they need to be anatomically designed and positioned so that take a real sample from that body area, from that muscle area. So it then represents the performance of that muscle group. In the picture, you can see all the muscles, skeletal muscles that we have been currently measuring and integrated into some of our clothes. One of the key benefits of measuring muscle groups with these large sensors is that it gives high reproducibility. So that means that once in the traditional EMG studies, every time you put the sensors on the skin, you actually need to make a normalization test, typically measuring the MVC and then always comparing the results each time for that normalization value. With this large textile sensor, there's no need to do that unless there's another reason for comparing the results for something. I'm going to get back to that later on with some of our examples. So it means that, for example, our core product, which is the shorts measuring the quads and hams and glute muscle groups, we have only 6 channels, but they are measuring 16 different single muscles at the same time. Our current product portfolio looks like this. So what we have different kinds of clothes. The shorts is the basic product for individual users or the team sports, but we also have shirts, both for sports and both for ergonomic purposes. Then we have a low back belt, which measures the low back muscles on the left and right side, including also the bending angle of the body. Then one of the latest products is a sleeve. This is intended for the ergonomic applications where we measure the wrist extension flexion muscles and also the wrist angle and angular speeds. So we combine the EMG and IMO sensor in this product. Also, the IMO is built in all these other products. And very latest launch was made yesterday. So we developed this kind of calf sleeve called M sleeve, which measures all the muscles below the knee area, 3 channels or 3 muscle groups on both legs. Then the signals are obtained and analyzed in different ways. We have a simple mobile app, typically for sports applications. Then we have 2 different Windows softwares. One of them is the muscle monitor. It's intended more for the scientific purposes, but also for the team sports. And the other software is developed for the ergonomic applications, where we combine the synchronized video recording together with the EMG and the IMO data. Then something about the technology in general. As mentioned, this is our 3rd generation technology, but it's based on over 10 years experience and feedback from our customers in different fields. It's based on state-of-the-art signal acquisition, real 1000 Hertz raw EMG, which is then further processed for different purposes. It also includes the capability of integrating other external signals like IMO, heart rate, power, etc., etc. And that means that we are developing this kind of integration combinations for the future for all these core markets. The clothes are very durable, they are easy to use, and they can be used even extreme conditions. The latest case was ultramarathon runner who used our shorts for 1 week, a marathon every day, and he got very good results from those daily exercises. We are using Bluetooth smart data transmission. Based on our experiences, it can work up to 50 meters, but of course it depends on the environment. In the internal halls, the distance is longer than in the open field. The smart clothing means that we laminate silver coated textiles, which take the EMG signal from the muscle area. Then, as mentioned, the IMO sensors are integrated inside our products, but also we can collect IMO data from external sensors. The product as such, Mbody 3 device, which is called M-Cell, that's designed so that it can be connected to any of our clothes, and the combination can configure itself automatically to measure what it's intended. So that means that there's little work with the software to make any adjustments. So once you connect the module on the cloth, it starts measuring exactly those things which are needed at that time. And the product is really compatible with the different end products like the mobile phones and the Windows software. And we can integrate the data from external heart rate belts, IMO sensors, power sensors. And what we offer, we have open API for other partners to be integrated into their own systems. The key benefits of the Mbody technology. Again, it's very easy to use, it's comfortable. It enables all the movements that the person or the athlete needs to do during their exercises or during their daily works. To start measurements, it's very easy. You just plug in the system and it starts doing what it's intended to do. The user interface is very simple to follow, giving lights, vibrations, and even sound feedback if that's necessary. The system is very versatile. The EMG as such, technically it's measuring 1000 Hertz raw EMG, but in most of the applications, the data or the signals, they need to be reprocessed. And what we usually do, we average that at 25 samples per second, which is the normal level when an endurance athlete, for example, does the exercises. Then we can collect all the major features and parameters from the muscles. Of course, there are needs for more accuracy, and for example, the IMO sensors in some applications require, for example, 100 Hertz sampling rate, so we can also configure the products for that purpose. But the standard is 25 Hertz. As mentioned, the combination with the device and the clothes can reach up to 16 channels, EMG or IMU and both. The API that we offer, there are two versions. There's a free of charge API that gives 1 Hertz data. That means that then the signal is really comparable, for example, together with the heart rate signal, which is quite a slow motion signal, and then when the muscle signal is the same frequency, they can be compared with each other. For the more sophisticated applications, we offer the 25 Hertz sampling rate with the license agreement. One thing about the clothes as such, they are fully machine washable, and they are durable. Our typical warranty is 6 months for a cloth. Then what is the basic Mbody 3 product? So it consists of the electronics module and the cloth. The MCell 3 module is very small. It's a matchbox size module. It contains the IMO sensor. The memory capacity with this module is 30 hours. It both regarding the memory and the battery capacity. So that means that in some of the research studies, the system has been used over a whole 24-hour recordings. So it's really helpful for the scientist to record long-term physical activity recordings over the day. It's rechargeable with the USB cables. The M shorts as such, there is a place for the module. The electronics is divided between the electronics module and the cloud, and that enables the automatic configuration what the system is measuring. The shorts are measuring the quads, hams, and glute muscles, which are very useful in the most of the running kind of sports, also cycling. We have different sizes starting from XS up to XXL. The model is unisex, so that all men or female can be using the shorts. The fabrics as such is very stretchable. It's a typical apparel used in sports clothing. What we can also do, we can tailor these clothes for customer needs. Typically, the scientific research institutes, they have their specific research projects going on. They specify the muscles, they specify the positions, the number of channels, and so on, and then we tailor the system according to the customer needs. Something about the basic use. So the MCell module is just plugged in. It automatically starts and configures itself to measurements. And then you can start the recording either from the mobile app or the Windows software. That means that then you can record the data online from the test subject, or you can do the recordings offline. Then you only need to use the push button on the module and you can start the recording, and the recording time can be then up to that 30 hours as mentioned earlier. What are the key features then that we provide? One of them is the total muscular loading. That means that we combine all the 6 channels together, then we get one single signal which represents the leg muscle loading overall. So this is what I meant when I told that it's easy to compare the heart rate and the overall muscle loading together. I will show examples a little bit later. Then the very typical parameter is to compare the left side and the right side legs, or the individual muscle groups. And then also what is quite important for the athletic purposes is the quads hams ratio. That means that, for example, a good runner needs to use the hamstring muscles more compared to the quadriceps muscles. So then when we show this ratio, the runner can see how well he's performing in this respect. On the other hand, a cyclist needs to use both the quads and hams nearly equal level. So that means the ratio is then different for the cyclist, which is very important, a new feature both for the performance but also for the injury prevention or in the ergonomic situations, is the relaxation parameter. I will get back that later in this presentation, but that means that we measure the very, very small signal values from each muscle, and we can detect the lowest level very precisely, and then we can compare that to the thresholds which are found out to be necessary to assess when you are in the safe level or not. Then something about the normalization methods that we are using. One of them is the muscular fatigue threshold. Then starting with the science behind, I think all of us know that the lactate is the key parameter to show when the muscles are starting to get fatigue. So the lactate threshold is very commonly used, but that lactate is collected typically from the fingertips or the ear. So then it means that the information from the blood is coming from the whole body, not from the specific area. But when we measure that from the muscles, then there are already scientific articles since 1980, so that from the same situation when the muscles are getting fatigue, an EMG curve shows a threshold. After that, the EMG starts increasing, not rapidly, but increasing anyway, so that can be detected. And there are different other thresholds, like the lactate threshold, the VO2 threshold, the EMG threshold, but anyway, they all represent something which can be used to monitor the training or assist the athlete to improve the muscular performance or the cardiovascular performance in different sports applications. So what we have developed this kind of MFT. So we identify this point where the EMC starts increasing, and if we compare that with the heart rate, from the heart rate curve, there is very difficult to find any point where the threshold is. From the lactate, it's quite obvious, as we know, but from the muscle curve load, which looks very similar to the lactate curve. So therefore, we have developed a test for this MFT threshold. So typically, the athlete needs to run 30-minute test. The first part is a warm-up, and the warm-up is really needed to make the muscles adapted to the exercise and strain. The last part of the test is 10 minutes, when the athlete is advised to increase the speed to the level which either is monitored by heart rate, or it can be also assessed by just own personal feelings, but that should reflect to the level where the person is running his or her cruising speed. Let's say, put it that way. But anyway, from this area, we then calculate the MFT value, which is identified, and then it's stored into the mobile app so that it can be used for further purposes. That means that the MFT threshold can be used to determine specific training zones in the similar way as is used from the heart rate threshold. And I have here a couple of examples. The MFT here is this yellow line. The red one is the heart rate, the same level for the heart rate. And this yellow curve here, in this case, the athlete has been running within this speed endurance zone quite nicely. Over half of the exercise time has been within this zone. In the other example, this is the maximum endurance test. Now the athlete has been within that maximum zone more than 70% of the time. So that this helps the athlete to focus the training to the muscles, not that much on the cardiovascular side. If you are running or cycling too fast, you will get exhausted, and then you will automatically reduce your muscular effort. But in order to enable the development of the muscular performance, you must stay within the muscular maximum endurance zone, because then the success of the training is much better than just monitoring the loading by heart rate only. So the Mbody Live mobile app is intended for regular training, and it assists the athlete to develop the speed, the endurance, the technical skills, and also what is important, to avoid getting injured. So all these four sectors are monitored during the exercise. So in a nutshell, the mobile app, it measures the muscle load here on the left side, and the heart rate can be connected with the heart rate belt, for example, and you can see both of them. So the muscle load and the heart rate at the same time. Once we are in the mobile phone, we have the data from the GPS. That means that we have all the timing, the speed, the distance, and also the altitude. So with one simple view, you can monitor your exercise situations very easily. For example, when you are riding a bicycle, you just put your mobile phone on the pedal, but not pedal, on the steering board, and then you can see where are you going at each time. Also, the mobile app has some other simple features. by sliding to the left on the screen, you can see the left-right balance or the quads and hams ratio. And also sliding to the other direction, we present the muscle graphics in this form. So we have here the quads, we have the glutes in the middle, and the hamstring muscles down here. And then the athlete can see whether the quads are in balance or glutes or hams, or if there's a difference which is too much out of the normal range, then the color coding shows that you are now out of the acceptable range. In this case, for example, the glutes are not in the balance, but the quads and hams are within the balance. Also, you have the quads hams ratio here, quads 52 and hamstrings 48. So in this basic view where we have the muscle load and the heart rate curves, at the same time, we have here the area which shows the selected training zone. We have 5 training zones in the same way as from the heart rate. And in this case, for example, the zone 3 means that it's the speed endurance zone, lower speed endurance zone. It's not very clearly visible. We have here a dot with, it's actually the MFT threshold. So if the athlete exceeds the muscle with the muscle loading over that threshold, the curve color changes to red. So that's kind of a warning sign that you have now entered into the zone where your muscles are starting to get fatigued unless you reduce the speed or the loading somehow. In the same way, we have the thresholds and the zones for the heart rate. But what is the difference is that this we all know that the heart rate changes quite slowly, but on the muscle side, this curve, it changes very rapidly depending on the situation. For example, when you are riding a bicycle in the flat terrain position, you might get the bike running alone. So that means that you don't need to use your muscles at all. So then the muscle loading is very low, but yet still the heart rate may be within the training zone. But then if you are climbing a hill, then you most probably need to go over the fatigue threshold on the red zone, but then you can control your effort so that you don't get into the fatigue level too easily. And this display is measuring and showing the data real time. On the other view, you can see the 1 minute trend so that you can monitor either the real time information or you can see what's been happening during the last minute. And then there is also, of course, this index, which is updated all the time when you are doing the exercise. So it's kind of a quality index for your exercise. Okay, in this slide, I have here the training zones. So when you have done the test and the threshold is defined, then these are the limits for the different zones. And the different zones, the basic endurance zones are usually used to develop the long-term endurance for fat metabolism and optimizing the technique. The speed endurance zones are intended to develop the competition speed endurance and lactate control and maintain the technique and maintaining the economy of the exercise. And when you are in the maximum endurance zone, that means that you develop your maximum skills. That means, for example, the final sprint after the 3-4 hour cycling tour, for example. and that means that you are then developing your tolerance to the high lactate levels. And this can be done so that before you start your exercise, you can choose this training zone with the simple sliding key on the app. Couple of examples showing how the muscle curve, muscle loading, and how the heart rate compare with each other. In this picture, I have two examples from the Cooper test, 12 minutes Cooper tests. And in the first example, you can see the speed has been very constant from the beginning till the end. But at the beginning, the muscle loading was quite high, but it was reducing. Typically, within 5 minutes, it reduced or lowered to the level which is your normal. And then till the end of the exercise, the muscle loading has been within this zone 4, and with some changes, as I mentioned, the muscle loading is a quite dynamic parameter, but anyway, in overall, the muscle loading has been on the same effort level whole time. But as you can see, the heart rate has been increasing and probably reached its maximum at the end. So in this case, the person perhaps should have stopped the running, or at least reducing the speed. In the other example, we have different curves. Again, the speed has been quite stable from the beginning, but in this case, the muscle loading has not been that high. But then when he reached the level, the normal level, he went to nearly to the end. But what is very important to see that he had more resources still left for the exercise. So that means that he made here, let's say, 40 seconds lasting final sprint. So the muscle loading has nearly doubled during the last 40 seconds. And again, the heart rate has been increasing all the time till the maximum. So this shows that the personal capacity can vary quite a lot depending, in the neuromuscular side, can vary quite a lot depending on the person, depending on the day, depending on whatever. And that means that it's very important to monitor also the muscle loading while still monitoring the heart rate. Some other examples we have here from the cycling test. I think these values were already shown in the earlier slide. But anyway, you can see here how well the muscle loading has been staying within the zone, but there are some points where the muscle loading has been very low during the training. And that looks like that there was a elevation, the downhill here part, when he didn't need to use the muscle loading at all. And the other case is here, where at the start there was a quite steep downhill. So that means that the muscle loading has been very, very low. Also the heart rate was low, but then when he started to ride more fastly, then the heart rate increased very rapidly, but even more increased the muscle load at the beginning when he started to that part. And also here, the muscle loading, there are quite large variations. And therefore, we calculate the amount of time within the selected training zone. Then the muscles also need to use in the gym training. And for that, the mobile app shows the muscle loading. In here, we have the intensity of the muscles shown here, and also the left-right balance with the color coding. And in this case, both the quads are equally contracted, but the right glute is nearly dead. The left one is having some activation. And also you can see that the right hamstring is compensating this glute muscle because it's higher compared to the other side. And then when you have record, you can also record the whole gym training. So you can see here, you can have still the same exact training load, but as you can see, the overall muscle loading starts increasing, and the last one, the muscle loading was at highest. So that means that there is some fatigue already occurring in the muscles. Then some examples regarding the Windows software. So we have two softwares for Windows. The other one is the ErgoLink software that is developed for the ergonomic analysis projects, but it also can be used for sports applications. And the key advantage is that we record the video synchronously together with the muscle data and heart rate data. And then the other software is called Muscle Monitor, and on the following slides there are some examples how they can be used. In addition, with the Windows softwares, we have the cloud service. This is intended now for the ergonomic projects. So once we conduct a project for industry, for example, we create the project into the cloud where we collect all the measurements, and then we publish the results and reports for the customer from the cloud. So we give access for the customer to this cloud service, and they can print all the reports there. This is a simple example of one of the reports here. This is the view of the Muscle Monitor Windows software. So what we show all the EMG channels and the IMU channels if they've been recorded. So there is a selection for all channels which you can show at each time. And then we have the total sum, which is a different curve on top of the screen. And from all the signals, we calculate some basic parameters here. And then we have lots of detailed values on the second page. And also all the data can be exported in CSV form for other use. But also we have simple graphical results presentation here, where we have the muscle loading distribution, the left-right balance, the quad-hams ratio, the distribution of paired muscles, and also we have the relaxation parameter, which is the specific one. I'll have an example of that later. This is the view of the ErgoLink software, how we collect the data. This is intended for the max VO2 test. So what we collected here is the heart rate and the overall muscle loading. And as you can see here, the test included the warm-up period, and then the actual testing period, and then the cool-down period. And for example, here you can see that the warm-up period, the overall muscle loading is somewhat higher compared to the beginning of the actual test period, and also somewhat higher compared to the cool-down period, even though the treadmill speed was equal during both the warm-up and cool-down. And then taking one channel to the specific review, we can see here, for example, the left hamstring. We can see here very nicely this curve where the muscular fatigue starts to occur. It's somewhere here. It is very clearly visible. And then when we zoom in to the different channels, I chose here the left leg channels, left quad, hams, and glutes. And from these signals, you can easily see, for example, the activation order of muscles during one stride. Actually, we are developing a specific algorithm to detect this automatically so that we can analyze the running skills from the muscles automatically. And in some of the future products, we will launch a feature for a runner to monitor the running technique and running skills, either on the mobile phone or on the smartwatch. Then going to some of the selected products. For the ergonomic purposes, we have this kind of product called ErgoAnalysis. It means that we put a shirt on the person in the factory, for example, like in this case. Quite often they also need to wear the shorts. That means that we measure 8 muscle groups from the upper body and 6 muscle groups from the legs. But also what is important, that we have the M-cell modules put on both arms. That means that we can monitor the arm elevations during the work. And also this monitor which collects the EMG, it also monitors the upper body leaning positions. And these are all recorded at the same time together with the video. And once we make the analysis during the project, we then create these reports and publish them for the customer. Then for the ergonomic purposes, we also have this product called ErgoSleeve, where we are using the Xsens dot sensors, and they are used to measure the wrist angles, the extension, flexion, and the radial ulnar directions, and also the angular speeds. And at the same time, we have here our own M-cell module, which measures the muscular loading from the wrist extension flexion muscles and also the upper arm elevations. Then one example regarding the rehabilitation, return to sports. This is an ACL case study. A marathon runner had this operation, and he was training with gym devices, but we also took his running examples like here. So as you can see here, that there was a quite large imbalance between the left and right side. And what is especially noticeable is that the leg which has been injured was the hamstring muscle was co-contracting all the time, supporting the quads area, which wasn't performing that well. So we monitored him month by month, and actually for him it took 6 months until all the muscles were again back in the normal balance. Even after 4 months extensive training, the contraction on the right hamstring was still there, noticeable. He didn't feel that, but with the signals we can notice that. And as I mentioned earlier, the relaxation parameter is very new and very important one. The relaxation means that we monitor the lower level of the EMG signal, in this case, the left hamstring muscle. As you can see here, the lowest activations start increasing from the 0 level. Actually, in this case, we have here the thresholds 12 microvolts. It exceeds the first threshold 12 microvolts here, and we can monitor that very easily. This is again something which the person doesn't feel him or herself. it must be measured and monitored. But you can see that how clearly there is a risk for injury. If this starts increasing to the second threshold level, then it turns to red, and then it means that there's a clear warning that now at least a cramp can occur in the hamstring muscle. Thank you. I think it's now time for question and answers.
Yes, thank you, Pekka. Very nice presentation, and thank you for sharing this really nice technology of Myontec. I think it was a really clear presentation because we only have one question, which is from Peter Collins. Peter asks you if you can determine the relative levels of activity for the antagonist and the agonist muscle. For example, just if you can see if just the agonist is active, or both are active, or the agonist is only active.
Yeah, that's very simple to detect with our technology. It just depends on what body area is measured, and then we can define that. I think the Quats-Hams ratio is kind of a type of analysis for that purpose.
Okay, Pekka, thank you very much